optimize some delivery routes for the Texas Spikes Youth Baseball Organization. My name is Daniel Frye. This is Anthony Taricco and Shelby. So today we're going to be going over an organization overview, the problem, our objective, models we use to solve our problem, and the results and some recommendations for our clients. So Texas Spikes is a nonprofit Christian-based youth baseball organization in North Texas. Their mission statement is molding young men on and off the field, and our point of contact for this project was Mrs. Lisa Hickman. So their problem was to figure out how to efficiently plan routes to deliver these bags of mulch that they sell during their yearly fundraisers. These fundraisers are held to produce some funds to enter into a few of their baseball tournaments locally. And the four products they sell are pine bark mulch, hardwood mulch, cedar mulch, and bags of compost. And their delivery date for this fundraiser was March 1st. So this is the picture of their old system. It was hand done using some handwriting as well as a free website that they found. It didn't produce step-by-step instructions, and they had no way of optimizing the routes themselves, so it was more or less a guessing game. So our objective is to reduce the transportation costs and time by finding the most efficient routes to deliver the products through North Dallas. And we figured the best way to accomplish that was to lower the number of times that these drivers must return to the staging area. And so some of the constraints we considered are the capacity of each delivery truck, the number of trucks available on the day of delivery, the addresses of each customer and the distances between them, and the customer demand per home. So now I'll hand it off to Anthony, who will discuss our first problem.
All right, well, I'm going to discuss our first approach to this problem. As we decided to cluster by zip codes because we did not know how to cluster to begin this project, and we had to learn about developing our process. And so basically we assigned each address to a truck based on the customer's demand and our objective was to minimize the number of trucks, and our capacity for each truck is 125 bags of mulch. We assume that to scale the problem down easily to make sure everything works. Here is a clip from some of our ample code. As you can see up top, parameters T and H are the number of trucks per route and the number of demand per house. One thing to state is we had to run the model for each area code, and we had, I think, somewhere like 20 to 30 area codes, so we had to run this 20 to 30 times. Parameter D is the demand at each house to make sure all the houses get their products delivered to. Also, if you look down here, here's our objective function, which was to minimize the number of trucks, and our capacity constraint is below it, and our demand constraint is below that right here. Our input files for our input data for each time we had to run the ample code. On the left is a number corresponding to spreadsheets and addresses, and the right is the demand at each address. Here's just a rough example of one of our ample outputs for, I think this might have been one of the area codes of Frisco. And as you can see on the left is the address numbers 1 through 20. That's how many addresses were in this zip. And across the top you see 1, 2, 3, 4. That is the trucks. And in the matrix, everywhere where there's a 1, if you look at the very top of that column, that means truck 1 is going to that address. If there's a 0 in that column under trucks 1 through 4, that means that truck is not going to the address. And on the bottom, you see over here is the capacity that's going to be in each truck. For our client, we had to deliver a map and routing. So we decided to use MapQuest because all we had to do was upload a CSV file, and it did the routing. It did just a basically shortest distance routing for that cluster. And also one other thing about MapQuest was we could give them, there was a downloadable file once we had the routes, and you could upload it to your iPhone and to the application, and it would just automatically bring in the route and all the addresses. So that was one of our requirements from Lisa. And some of the limitations that ample We could only cluster by zip codes because we weren't quite sure about the functionality and if there was functionality in Ample to do clustering. And also the output was not really user-friendly. We had to run it, 30 something times, and the input wasn't friendly. We had to change it for everyone. Some of the zip codes had over 100 addresses. Also, we had to create a data file for each cluster because, as I said before, it was the data. We received the data in different spreadsheet formats that most of the kids did, and so we had to sort through all that and deliver it all to be able to upload it and bring it down from Ample. Now I'm going to pass it over to Shelby to talk about our second approach.
We had a very limited time, like the senior design project was a little different in that we had to deliver our approach by March 1st. So we kind of felt like we were limited to Ample, and it didn't give us all the functionality that we needed, and we figured that clustering was actually really important in this problem because some zip codes, like even though that was an okay way to do it, there would be outliers that wouldn't make any sense with zip codes. For our next model, we wanted to kind of challenge ourselves and do it anyway and still try to find that most efficient way, even though we had already delivered to the client. So we tried to research a lot of different softwares, and the one that we found was the best just for the clustering aspect was IBM SPSS. And we decided to do two different clustering methods within IBM SPSS because hierarchical, I'll talk about that one a little more. It'll give you a kind of idea of how many clusters, but it won't necessarily tell you how many. You have to find it within their own data. And then K-means clustering, we would have just used that one because it's more accurate, but you have to know beforehand how many clusters. So we were going to use hierarchical first, and then use K-means later to form those more accurate clusters. Okay, so for the hierarchical cluster, we used the square Euclidean distance formula to find, they would take the different lengths between the addresses and then square them to place more weight on the ones that are outliers, like we were having trouble before. So this is just a little bit of the formula. And the reason why we chose the square Euclidean distance is it's commonly used in optimization problems to compare different distances, so we felt like it was really perfect for our problem. And then we used the nearest neighbor cluster method to actually form those clusters. And that basically just uses that distance formula and takes that distance plane and tries to put the different clusters together. So it doesn't do it perfectly like K-means, but it gives you an idea. So if you go to the next slide, they have a SPSS to have this agglomeration schedule, and that's how you find the different clusters. So it looks really confusing, and I don't know if you can see very well, but this middle column is the mean distances from every address. And so what you have to do is you have to look at where that coefficient jumps. And that was here at stage 37 is where it had its first jump. And since there was 41 stages, you're supposed to subtract the number of stages minus the stage where that jump occurs. And that'll give you an average cluster amount. So that was 4 clusters. We then put those 4 clusters in a K-means clustering system. And what that does is it basically it knows that there's supposed to be 4 clusters, so it finds 4 like centroids all in the distance plane. And that's what you see up here is the longitude, those 4 different addresses that are like the main centers of that cluster. And this is just an example one. So we had about over 600 addresses, but we took 42 of them to use this sample. And the 2 of those are our addresses, basically, my name. And just to test, because they were farther away from all the other ones. So we just wanted to test that that distance formula was actually working and that they put those 2 together. So that's why there's only 2 in that one. And then the really neat thing about K-means clustering and SPSS is it'll save the cluster membership. So when you go into your Excel file, it'll say like this address is in cluster 1. Like it just automatically adds that and puts it all in an Excel database for you. So that was really neat to have. So because it did that, we decided that we really did like the functionality of our first approach where we would base the routes on demand because we had gotten really good feedback on our client about that. They were always running out like right when they were supposed to drop off. So we created an Excel macros to do basically that same thing. So it looks really complicated, so we won't like talk about it line by line, but this is the little snippet of our VBA code. So we used this Visual Basic Editor and made a code in a little macros. So I'll just go through the logic of it. So at first it would sort through the columns of
So we found that SPSS statistics gives a much more accurate representation of geographic clusters than we could using AMPLE and zip code clusters. Using their old approach, Texas Spikes would have taken over 24 hours to deliver to all of the different homes that they had this particular year. And all the feedback from our client was very positive. There was no confusion in executing the routes that we provided to them. We recommend, because our client doesn't have access to SPSS software, that they continue to group using zip codes and then use our macro that we built in Excel to assign trucks to those groups. We also recommend that they have as many delivery trucks as they can because that only makes the process shorter and easier for them. We also recommend that they aggregate the customer data in the format that works with our Excel macro that we built. Any questions?
So I guess one of the questions I have is, the objective would be to minimize the number of trucks, because in the conclusion, you kind of say they should have as many trucks as possible, or is it minimize time?
Minimize time. Our main goal is to minimize the amount of times that the trucks would have to go to a group of homes, then come back to reload. We wanted to make sure that they have the exact amount for a particular group of homes, so that they wouldn't waste time traveling 30 minutes, 40 minutes back to the staging area.
And the minimized number of trucks was just, if that made more sense in our ample model, just kind of running our ample model that way, but that wasn't like the overall objective of it.
So your new approach, the SPSS, clustering model, did you kind of go back and look to see what results you would have had, how the clustering would have been different versus the zip code model, and
Yeah, we like
how
ran,
much more efficient might that have been?
we ran it like through the routing system, so we would get these routes, but then we'd have to take them through like MapQuest to see the time and like deliver that to the customer. So when we did that, the MapQuest routes like made more sense. We kept getting routes that were like those outliers that were just really far, and we just did not have that as much the second time. So that was like, they didn't complain about that, but when we were going through that and like sending it to them, we were like, well, we feel really bad because one truck is gonna have to go like way out of the way. So it was efficient for them because like that was our first model. It was efficient for them because it was better than their old system, of course, but we had wished that we had given them this one so they wouldn't have as many of those outliers.
Right. And in the SPSS model, is it two methods that you looked at, or is it really kind of two-step process going from the hierarchical to the k-means, or are those
Well,
two?
we're usually two separate methods, but for us it was just kind of like a two-step process to get that cluster.
Okay.
We wanted, so like for some people, hierarchical does all they need, and then for some k-means does everything they need, but for us it just made more sense to, since we didn't know the amount of clusters, we would have chose k-means, but we didn't know the amount of clusters going in.
I see.
So it was a two-step process for us.
One is determine the number, and then separate. Other questions?
Personal.
Yeah, so they have a Excel-based system they can use next year.
Correct.
Yes.
Did you design a template for them for filling out the orders?
Yeah.
Because you
Well,
said you recommended something about they should use a standardized
yes,
spreadsheet.
the way our Excel spreadsheet is set up, it has the homes listed by address and with their demands, how much that home ordered in the different bags of mulch. Then it has a column that would be filled in when we ran it through the SPSS software, but if they're using the zip code grouping method, then they can add in group numbers themselves. Then the macro will run automatically and assign
Yeah, so
trucks
it's
to those.
basically their old template, and then we added like a total demand column for the macros, and then a cluster membership column. So that was really the only two. It's theirs, but they have to add those two columns for our macros to work because it works with those two.
But somebody still has to take those paper, and you showed that one slide where they had the orders.
Right.
Oh, that one, yeah, that was just the old system, but the orders, yeah, I mean, it's a piece of paper, someone has to do that. So we were, another way we think about activating it was telling them to use like a Google spreadsheet, because they're all just kind of inputting them into their own separate Excel spreadsheets and then trying to put them together. So it would just be more efficient.
There was really not much of a rhyme or reason to how they recorded all of the orders. There were a few questions that we had to ask to clarify exactly what home ordered what. So if they had a very standardized way of listing everything out, that would make it a lot easier for them.
So are these kids that are going door to door selling them?
That's
Yeah,
the
Is that-
thing.
okay, that's why, that's probably
So
why.
it
it's
was
like
kind of
that.
hard, yeah, for us to get all the data.
What were your clustering criteria? Was it just simply in terms of distance from each other? Or was there some other things?
It all is in North Dallas, so that was basically, there's not too much distance, but there kind of is. So we decided to do just distance, and then later we would do like a demand thing. But just for the clustering, it was just mainly on distance, so that we could make better routes for them.
And the distance was, like as the eagle flies, right?
It's more important.
Yeah, it was latitude and longitude, so. Our first one wasn't, but
So you should use carriers.
yeah. We hope like, and then I think MapQuest would tell you if there was an issue with that. So it's good that we're using a software that they can use and that they would be able to see if that's not okay and then add it to another route.
Question? So what did you enjoy most about this project?
Learning how to use new software, familiarizing ourselves with SPSS and Visual Basic. I used SPSS in one of my classes a little bit, but not to actually accomplish something
And
like this.
the hardest thing at the time was learning it all, but then I think now that we actually like, can say we know SPSS really well and then we know Visual Basic, which are two things that can really come in handy. It's like, it was bad at the time trying to figure it all out ourselves and self-teach, but I think it's really good at this point. Looking back.
It's good, because, I mean, that's what we do as management scientists, we're always learning a new tool. It's,
We had to keep trying different software, so that was really rough, but we finally found one that works really well.
yeah.
I was impressed with your short initial deadline. I remember like
Yeah.
2 weeks into the project, you gotta have a solution.
Yeah.
But then
And
you,
it turns something around real quick.
That was
Yep.
basically our life for a good 2 weeks.
and then you came up with an even better solution. That's good.
Yeah, we had a good like 10 to 15 addresses that didn't check out,
And there were problems.
like actual locations and whatnot, and like neighborhood developments that had like a gate address that we had to figure out.
More constraints to be added to the next iteration.
Yeah.
Anything else? All right, thank you.
Very good.